Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for UW Extension Cooperative Extension. And on behalf of those folks and our other co-organizers, Wisconsin Public Television, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight it's my pleasure to introduce to you Norm Dahl. He's with the Civil and Environmental Engineering Department here. He was born and raised in Slinger, Wisconsin, over there in Washington County. He came to UW-Madison and got an undergraduate degree in civil engineering. He worked for an electrical company called Pieper, thank you. And now he does work all over the world with Heifer International in part, and that's what we get to hear about tonight. I'm a big fan of both physical and social infrastructure, and tonight we get to hear about how civil engineers like Norm get to help build spigots and toilets that are connected to systems that can actually bring fresh water to people and manage sewer by taking it away from folks and keeping them healthy. It's an unsung thing. I think it's one of the most important things we can be doing. Please join me in welcoming Norm Dahl to Wednesday Night at the Lab.
Thanks, Tom, and thanks again for coming out this evening. So tonight we're going to talk about some sanitation issues around the world, a few different spots that we'll look at and the problems that are going on there and sort of the origin of those problems and then some potential solutions. Mostly we're going to focus on rural development for particularly small shareholder farmers. But I am going to touch on some urban issues as well as small rural town issues, and you can sort of see how these things have gone awry around the world from quite a few different places. So if you want to reach me, that's the best way. Just send me an email at that email address. I'm a professor of practice over in civil engineering, so I have an adjunct appointment there. I'm also a licensed professional engineer. I'm a consulting engineer currently for Clear Horizons out in Waunakee and Waterloo, Wisconsin. And I'm chairman of the board of the trustees of Heifer International Foundation. And I'll explain a little bit later what Heifer does. So in my classwork here with students and groups around campus that I work with, I always start with why and try to make sure people understand why they're doing what they're doing and then move on to what. So these are the whys for me primarily. You know, what's happened, we're going to, unfortunately I did pick Nepal as one of the countries. It's one of our most successful countries, but I picked that prior to the earthquake. And 5,000 people have died there at least, and it's a horrible thing for sure. But the fact is roughly 22,000 kids die every single day from starvation and preventable disease. It's not newsworthy anymore. Everybody gets sick of hearing it on the news every night, but it is a fact. It's also better than it used to be. Maybe 10 years ago it was 30-some thousand kids per day. So things have improved even while the population's grown, but it's still a major, major problem. The other group that suffers horribly from the lack of food and proper treatment are women. They're horribly discriminated against around the world. They get fed last. They do the primary work of farming. And so that's the other group that causes me to do what I'm doing. Small shareholder farmers provide 80% of the food supply, particularly in sub-Saharan Africa as well as Asia. The world population is estimated to be 9 billion by 2050, so we're going to have a food issue. It's always been a distribution issue, but the small shareholder farmers do produce the food in that part of the world, so they're a very important group, no doubt. They also feed themselves, of course, and so if we can make small shareholder farmers successful, it has a big impact on what's going around the world as far as starvation. Heifer does sustainable, holistic development. I'll explain a little bit later what I mean by that holistic development. They build social equity and then they leave before dependence. So they go into these communities, they do one iteration of their program and they move out. And for me, that's a really important thing. They're highly successful with what they do because of how they do it. So what we're up to here is we're working with community normal standards, what communities do normally when they build what they build and what they do. And that's a really important thing because when we show up in those countries and we try to impose what we do in Western developed society, it does not work. And I hope I've got some pictures that depict why that is. We want to develop a legal framework that enables our volunteers to work freely but responsibly on their projects. We have a problem with that here. We've done some great work, but we haven't been able to distribute it because of some legal liability. So that's another thing that that's one of our goals, to get that done within the next year. And then ultimately end up with usable standards that we can give to NGOs like Heifer International that they can use on their projects to provide a toilet in every case. So first we'll talk a little bit about urban problems, the slums around the world. I've picked Kenya and Nairobi, one because I've been there, two because they have some of the worst sanitation problems, but it could be anywhere. These slums are gigantic. They're all over the place, whether it's Mumbai or Jakarta, plenty in South America, Rio de Janeiro, Venezuela, Lima, Peru, and Mexico City, where the largest one is. The ones in Mexico City, however, have basic amenities. They don't have such a sanitation problem like they do other places like Nairobi. They've done a really good job in Nairobi in the last 10 years of providing fresh water. They have fresh water kiosks like the one shown here. They've largely eliminated the corruption of the water problem there. It was a big problem. Some operators would tap into the water lines and decrease the pressure so that by the time it got to the needy places, there was no pressure to push the water anymore, and then they would charge large sums for people to fill their buckets. So that's largely been taken care of in the Nairobi slums. But there's always a problem when you end up with too much water, and that is you end up with sanitation problems. And it's curious how around the world these sanitation problems have grown after people get water. So if you go into a community and you ask them what they want and what they need, if they don't have electricity or water or just about anything, they're not going to tell you they need sanitation first. They're going to choose water and electricity and food to keep alive. But then the sanitation gets ignored, and it has been largely ignored. So here in the slums around Nairobi, particularly the Kibera slum, if you've traveled to Kenya and you drive north out of Nairobi, you can't help but miss these things. You drive right through them. They're gigantic and go on forever, big, large shanty towns. And here you can see the effects of having water, plentiful water, that you end up with these open sewers around the buildings and around through the town. And they're all over the place. Wherever you travel in developed nations, you find these open sewers. And it's particularly exacerbated when there's good water supply. So that's a problem. The current solution in Nairobi, as well as other parts of the world, is being pursued by this company, Sanergy. They create basically portable toilets, although the one you see here is a building. And they work pretty much like portable toilets you see when you go to a festival in Wisconsin in the summertime. They have to be pumped daily. What they do is they set up franchises, including in Asia, and they pump these things out or scoop it out, and they put it in buckets, and then they collect it and do nutrient recovery. So that is the big source of their revenue to get this work done, is the nutrient recovery. So they treat the solids, they separate the liquids, and then they end up with usable products that they can sell to small farmers, particularly for animal crops where there's not a problem. It's kind of okay, but there's problems with it. Number one, I don't know how sustainable it is to go collecting all that waste every day from these toilets. It's a huge job. And additionally, you can see that it does not eliminate the gray water. You see the little stream still in the community. When we traveled around to these countries with students here from the university, we've tested that gray water, and it really carries a bacteria count that's very similar to black water. So not getting rid of that stream, that gray water stream, doesn't solve the whole problem. It certainly is better, but it doesn't solve the problem. So I don't know how long that will last, but it is currently about all that's being done in these large slums, including in India. We're not free from these things in the United States. We have colonias along the border with Mexico. It's estimated that 500,000 people in the United States live in these things, 50% of them without a toilet. They started when landowners along the borders started selling small and renting small plots of land to illegal immigrants and other people who were legal in the country. There are plenty of people who live in these colonias who are legal U.S. citizens, and no one really quite knows what to do about it. Texas is working very hard on it. There's about 1,800 of these colonias in Texas, and then quite a bit less in New Mexico, Arizona, and California, just in the hundreds. So Texas is the one who's ended up with this problem. They're not sure what to do about it, and it isn't much different than what we find in the slums around the rest of the world. So now we'll move on down to El Salvador. This is where we've done quite a bit of work with students here from the University of Wisconsin. Sanitation work. And we did some great work down there. We worked in two different departments. Find my mouse here. One of them was in a town called Nejapa, which is right about there, between Quetzaltepeque and Napopa. And the other was down in the Usulatan district or department for two towns called Batris, Concepcion Batris, and El Tránsito. So these projects consisted of connecting a couple of small rural villages to the Nejapa wastewater treatment plant. They were Nuevo Ferrocarril here, that community. The location of La Granja. La Granja was not actually a community. It was a refugee camp during their civil war about 15 years ago that turned into a community. And then the other one, which was partially connected, was Calavejea. That community had some waste collection going on, was pretty developed. La Granja was not very developed at all, and then Nuevo Ferrocarril was also completely developed with streets and curbs, but no wastewater collection. So the Rotary International, working with the West Bend, Wisconsin Rotary, near Slinger, hired the University of Wisconsin students to our Engineers Without Borders chapter to go down there and build pipelines and connect those three communities down a pipeline crossing this portion of the Pan American Highway over to the wastewater treatment plant in Nejapa, which was right about here. All sounded good on paper. So this is Vieja, Calavejea, and this is what happens. There's lots of clean water in Central America, particularly El Salvador and this area. The bulk of the water for San Salvador, the capital, came from this area, from deep wells. So lots of water, and each house has a little half-inch pipeline, runs maybe 6 hours a day, pressurized by pumps rather than water towers. And once they get that water, they start using it, of course. Not only for bathing, cleaning, and cooking, but we started going into their homes after we got to know them. We worked there for about 7 years, and we found toilets in these homes, even though there were no sewers. And so what you find are these open ditches for sewers. They keep them clean. You know, if they plug up, they end up with a problem, and they all run down to the rivers. It's estimated in El Salvador that 90% of the surface water is contaminated. About 98% of their human wastewater goes untreated. It's just dumped into all rivers. Some of them, like San Salvador, which is fairly close to the ocean, go directly to the ocean. So you find these open sewers all over the place. Down here is one of the pipes coming out of the house, and that's really what they do. And I don't want to pick on El Salvador because this goes on all over the place. They run a pipeline out of the house. They have a squat toilet inside. Sometimes we found some homes that had full bathrooms with showers and full flush toilets, and then they just run it outside. And they'll dig a little ditch to get rid of it. They use a lot of soap. The Salvadorans dress like way better than I do. They like clean clothes. They like to have fun, and so they use a lot of soap. And that soap is just everywhere. It's you go into the rivers, and there's a lot of bubbles in the rivers from the soap. The animals, I have a picture of a dog, a lot of stray dogs in Central America, which is another problem. They carry a lot of disease. You have to be careful that you don't get bitten by one. But it's not only the dogs that hang around in these little open sewers, it's the chickens, it's the kids, it's everybody. People are walking down the street. You can't really avoid them all the time. These are pretty small ones. Some of the streets have really big ones. And so Rotary International, what their goal was for us to eliminate those open sewers in those three little communities that I showed you. So our students did a terrific job. They went down and surveyed the entire area, and then laid it all out with the contours. This was all done without electricity or lift pumps. In Madison and Milwaukee, we have lift stations all over the place. The pipes go downhill when they won't flow anymore, and there's a lift station that lifts the fluid up to the next level, flows downhill to the next lift station. They're everywhere. So the assignment here was to do it without any lift stations, 100% gravity. So they did just a great job laying this all out, and then went there and surveyed and laid out the lines and worked with the locals to lay the lines. So it's real easy to collect the fluid in reality. It's not very hard to build these pipelines. It was great civil engineering work for students, a great cultural experience for them. All of the layout work was done here on campus, and then twice a year we would go down there and work with the locals to install the lines. They could do this work themselves. They've installed these before. It was a matter of money, really, to get this done. La Granja was a very, very poor community. There was no money to do any of this work. There was a church there that had a sister church in West Bend, Wisconsin, which was how the connection was made and how they got us to go down there and do it. So it was pretty much all funded by Rotary International, and the project went very well. It's all in place and working. All of the sewers in the town are gone. They're not there anymore. But here is the problem. So when we went, they had this wastewater treatment plant which consisted of an IMOF tank, an aeration basin, and I'll show you these parts, and a biofilter. And initially when that plant was built, it probably worked pretty well. We were told initially, we were guaranteed that the plant was operating well under capacity, and that's how this slide was put together. This was one of the slides presented to Engineers Without Borders International, who approves all the projects. We weren't allowed to go to the wastewater treatment plant for a few years until they got comfortable with us. They were pretty protective of it. It was a nicely designed facility, but there's some real serious problems with it. So an IMOF tank is a small, they're usually pretty small. You build more of them rather than big ones. And the way it works is the influent, or the raw sewage, the raw wastewater, comes in normally towards the top of the tank, flows in. The solids settle out and go to the bottom. And then the effluent, the water effluent, the liquid, just rises to the top and goes either out a pipe like this, which would be similar to a wastewater system, a private one that you might have in a rural home in Wisconsin, or over a weir. So the fluid going out of there looks pretty good. It's pretty nutrient rich, however. This doesn't do much to take the nitrogen out, or the phosphorus for that matter, but it's pretty clean. The suspended solids are pretty much taken out. The solids collect and fall down and go down into the bottom where they digest, and that's why it shows the bubbles there. Because it digests, and of course you end up with biogas then that bubbles out of the surface and just goes into the air. They really work pretty well, combined with other systems that take the nutrients out of the liquid. They can function pretty well and do a pretty decent job. The problem is they have to be pumped out, and if the tank is too small and can't handle the volume, then it has to be pumped out on a regular basis. There's only one of these left in Wisconsin up at Baraboo. That is still owned by the U.S. Army. It was at the Badger Army Ammunition Plant, and they, as part of the whole deal up there when they were assembling that thing, they agreed to treat the wastewater from about 100 residences nearby. It's the last IMOF tank in Wisconsin. The DNR, when the Army turns that all over to the community up there, the DNR will demand that thing be removed and treatment improved. And that tank is probably, a little too small for the 100 homes, but the 100 dwelling units. So it has to be pumped about every 3 months. Normally, if the tanks are big enough, they could be pumped every year, even some more, because similar to a septic tank in a home treatment system, if the digestion's working very well, oftentimes people don't ever pump their septic tanks, even though they probably should. So that's the problem down in El Salvador at that tank, is that here's the top of the tank. I've got some other photos of it I'll show you. And so the way the thing was built, it was very, very difficult for them to clean it out. And here it is. This is the top. And so to clean this tank out, they would have to stuff a hose down through those holes sort of wiggle it around, and these are big 6-inch heavy-duty rubber hoses, and get it down in there and sort of move it around, and then have a very big vacuum pump to draw it out. Vacuum pumps don't work, they don't work as well as a push pump. So you have to have a really strong vacuum pump to suck those solids out of the bottom of the tank. Also very expensive for them to bring a truck in. They don't have any money, and so that tank was probably never pumped out. They had no records of it ever having been pumped out. Over to the right, and so this picture I took in 2009, and so the tank, this had been built in 2002, so it was about 7 years old. And here is the biofilter to the right, over here, and that should be all clean with plants. The fluid should be moving through it very slowly and cleaning it, and as well as adding oxygen to the liquid as it's going through the plant. So you see that it's overflowing. It couldn't get through the biofilter good enough. It's a little hard to see in the photo, but there's some piles here. It got clogged up. When these Imhoff tanks fill up, the solids just flow right through the liquid and into the final treatment area, and it just simply clogged it up. So they were proud of this thing. They liked it an awful lot. They were very proud of that Imhoff tank. Remember, in El Salvador, 98% of the wastewater isn't treated at all. So they were very proud that they were treating their wastewater. However, the thing was not working. It was even a little bit worse than not working. So this is the Imhoff tank up in Baraboo at the Army, down towards the south of the Army ammunition plant up there. This has plastic covers over it instead of those big concrete things. It's got little hooks on that they can lift off with a real small little forklift and a boom on it. They actually are light enough that 4 people, 1 on each corner, could carry it away and get it out of the way. I've been up there before when that tank was completely open, so it's very simple for them to get in there and do whatever maintenance they need to do. Additionally, in this pump house next door, they have a pump buried at the bottom level same as the bottom level of the tank. And there's a pipe system coming out of the side of that tank. So all they have to do to clean that tank out is flip a switch. And so every 3 months they flip a switch and suck all the solids out, put them into a solid drying bed, which is up the hill here. They don't reuse the solids, they just sit in there, and they grow grass over the top of them. But it functions very well. It's very well maintained. It's very easy to maintain. If they have any problem, they pull a cover off. They can get down in there. They'll send a diver in there if they have to repair something down inside that V structure that's down in there. They also have these pipes that they can hook a vacuum pump up to if they need to, if they have trouble with their other piping system. So this would be very simple technology to install at a plant down in El Salvador or anywhere else. You could build the tank into the side of a hill, keep it up out of the water table, put a pipe at the bottom that the solids could be easily pumped out with a simple pump, or even gravity flow for that matter, and then having plastic covers that you could remove so you could get down in there so you could clean the thing would make it feasible. And unfortunately, that is what happens in these developing nations. Somebody decides to build something like that, and it's hard to say where they come up with the solutions to the problems or how they design these things, but they just don't take practical maintenance into consideration. So we set up our own lab down there in El Salvador, Nejapa, and we started testing that fluid. They gave us permission to do that. And in fact, the effluent was worse than the influent. And that sounds almost impossible, but if you think about it, the tank had completely filled up with grease. It had a big grease crust, and it was full of solids. So as the fluid was moving through, it comes out of the tank over a weir into this, what is an aeration basin. The purpose of the rocks and the formations in there is to juggle the water so that oxygen is put into the water. But you can see that the water has a lot of solids in it. That water should be pretty clear. And the first time we had seen the plant, no pictures, that water was pretty clear looking. So what was happening was it was picking up solids in the tank. So it was worse going out than coming in. Here's the biofilter. That should be a nice green field of plants. It's completely clogged. It has to be completely excavated. All of that would have to be completely disposed of. My doubt that I would doubt that that would ever get done, that they'll ever clean that out. So in our civil engineering program, as in many of the engineering programs here on campus, the seniors in the senior year, the students have to complete a senior design project called Senior Capstone. And a few years back, we started offering a lot of different projects and real-world projects for them. So currently today, there'll be 80 students in that course next fall. We vary between 40 and 80. It floats around for some reason that we don't have a complete handle on. But so we'll have 40 to 80 students in the class, and they'll have a choice of 10 projects. And we were giving them these projects. So the town of Nehapa, when we proved to them that their plant wasn't working, that they were making matters worse rather than better, we felt pretty bad about it, that we had been drawn into this project that really didn't solve anything. All we did was move the problem out of those communities and the open sewers downriver to another community. So we had students redesign the plant for them. We had 3 teams that chose this project. They came up with great solutions. This team, this is right down where the plant was. This team was going to put in 2 more IMOF tanks and 3 large lagoons. And lagoons are just an open pond rather than a biofilter, which work a little better. So if a lagoon gets filled up with solids, you just go in there and excavate it out. You don't have to replace all the media, and you don't have all this porous rock that had filled up with solids. So we had some great solutions, but unfortunately, we weren't able to give them to the community because of potential legal liability. Engineers Without Borders provides liability insurance, but they won't do wastewater treatment plant projects because of the complexity. They have to approve every project and go through them. So that's one of the goals, and I'll talk about that at the very end about what we're planning on doing about that. So the other town I showed you there was Concepcion Batres down in Usulatan, El Salvador. And this is another kind of town, a totally different than those open sewers. So this was Batres, a pretty little town, a very safe little place. We liked it there an awful lot. It was very developed. And you can see in the upper picture there, it had curbs, gutters, streets. And they had, before they paved all their streets, they actually had put in wastewater collection. So the entire town had wastewater collection. So if you were there and you had a home, you would automatically connect your toilet to that system because that's what it was there for. But then what you see on the bottom picture is their outflow. So the entire town was pouring this untreated raw sewage out on it developed into a small creek alongside of a road and eventually went down to the river of San Miguel. So here is the path. Here's Concepcion Batres, so this is the town, and they had this pipeline go out this way and end up with this little creek. There was what they called the wastewater waterfall, which is what I showed you there. And this is El Tránsito, the other town, which goes right here. So that little creek ran right through El Tránsito, this little dirty creek. So they had this long wastewater stream all the way down to the River San Miguel. And so we also designed a wastewater treatment plant for them. This group had two sites that they had picked. It was also a lagoon plant. They had some very creative solutions. They were also going to use IMOF tanks. IMOF tanks, the design of them is rather complex, sizing them and making the shape of the funnel inside there. And the funnel's usually built out of some sort of wood. Like in South America, they would use some sort of wood that doesn't rot, like Ipe from Australia or something like that lasts forever. But the construction of them is very simple. So they're very, very popular. They like them there because they can build these things with very little help. They have standard designs, so you don't have to redesign it over and over. You can just, rather than resize the IMOF tank, you can put in 2 or 3, however many you need. And then for secondary treatment, outside of the IMOF tank, you can run the fluid over to a lagoon and just let it sit there, collect oxygen, drop all the solids out, and then have multiple lagoons. So you'd go from one lagoon to the next, and by the time it leaves the lagoon, it's really pretty decent fluid going into the rivers. We used to do that here in the United States. But again, unfortunately, we weren't able to give them the work. And I don't want to paint some sort of a picture that anybody was mean around here or the legal department of the university just didn't want to cooperate. It's not like that at all. The problem is in these developing nations, if you give them a set of drawings, and I have a good depiction of this in a minute. If you give them a good set of drawings on paper, as far as they're concerned, that's great engineering, and they just go ahead and build it. They don't have anybody check it. They don't look at it for their local standards, and they do have wastewater treatment standards in El Salvador. So we know that if you give them a set of drawings that was produced by students here, they'll just turn around and build whatever you give them. So you do have to be very careful. So we've got a plan in place on what we're going to do about that to try to overcome that problem. We stopped doing these projects for the time being with our students until we're able to figure that out. So they came up with terrific solutions and terrific plans, very professional looking. The students give themselves a name. They pick a company, and it's to prepare them for what they're going to face when they get out into the marketplace and work for an engineering firm. So they act like a regular engineering firm, but the impediments are the implementation for the legal liability problems. So now we'll move a little bit on to Nepal, and I apologize for talking about Nepal and something I'm not talking about the earthquake problem. I had finished this before the earthquake happened, and so it's very unfortunate, but they'll survive. It's a great country. I picked Nepal. It's a place where our heifer projects work almost better than anywhere else. They're very organized. They have very strong religious communities, and the government, at least the administrative and bureaucratic arm of the government, operates pretty well. They really do want to make things better there for their citizens and are working very hard to do so. So we're going to look at a place in Nepal that's south of Kathmandu, down here near the border, down in this area. It's near the border with India and not very far from Bangladesh. There's a variety of different problems down there. In the north of Nepal, this is where the Himalayan mountains are. There's Mount Everest. It's very high elevation, but it drops rapidly down here to a pretty tropical climate. So it's a lot different than northern Nepal, even though that's not a great distance. A lot of problems with animals down there. There's free-roaming tigers that eat the farmers' animals, and so they've got a lot of difficulties to deal with. It's a very, very poor part of the world, as well as Bangladesh. Nepal is primarily Hindu. There are Muslims that live there, as well as Buddhists. Bhutan is almost all Buddhist. In fact, I'm not sure that you can live in Bhutan unless you are a Buddhist. The work in Bhutan, the construction work, is done by the Nepalese. Bhutan's a very wealthy country. It's currently a monarchy, but changing to a democracy. But the monarchy has allowed them to do a lot of infrastructure work. They have huge hydroelectric dams there to sell power to India. They're in Nepal as well, but the Nepalese citizens are actually quite environmentally concerned, and so it's pretty difficult to dam up a river in Nepal, but not in Bhutan. And then Bangladesh is Muslim. So you have these countries, and they're very they don't welcome the other religions very well, but it does work well. Bangladesh put a toilet program in place that Nepal has sort of copied and has really been very successful getting the toilets to their citizens, as well as Bhutan. And it's pretty much, what we saw was pretty much the same toilets in Bhutan. We didn't travel into Bangladesh, but we did travel into India. So they're building this same toilet in Nepal, Bhutan, and Bangladesh, as well as now India. So this is one of their flush toilets. It's a squat toilet, which is what they prefer. It probably has something to do with they really are still using open defecation, and so it's how they're used to going to the toilet. So they really prefer this toilet over a Western-style flush toilet. The flushing is done by that bucket of water. The idea is that they'd have a bar of soap in there, and they would defecate into the toilet and then use the water out of that bucket and also wash their hands at the same time. The problem is, of course, that soap costs money, and so soap is a problem. There are quite a few groups working to try to get soap into all the toilets in the developing countries, but that's a real struggle because of the cost. So the alternative is open defecation. And I chose these pictures because the Taj Mahal is there in the background. And if you haven't been to see the Taj Mahal, it is something you might put on your bucket list. It is one of the phenomenal structures in the world for sure. But right next door is everybody living there. I mean, it's heart-wrenching to be there because to get to the buildings, you walk quite a bit. The parking's quite a ways away from your bus. And you're walking through a lot of people begging for money. It's very difficult to walk through there and see what they're faced with. And this is what they do. They open defecate in the fields because they have no toilets and they have no place to go. And then the same water that, of course, when it rains, the runoff is carrying the solids and the waste into the rivers and the waterbeds, and then they use that same water to bathe in. So it's a disaster. It is where the death comes from, the preventable disease. And then, as I'll mention here going forward, what we've learned is that when you ingest the bacteria and the worms from all of the pollution, you get a disease called enteropathy, and that prevents your body from absorbing nutrients and calories. So what I've been pushing Heifer International on is it doesn't do us any good to go into a country and solve the nutrition problem without the sanitation problem, because it doesn't fix things for them. You have to fix the sanitation, and it's just simply been ignored around the world for far too long. There have been a lot of groups that have been looking for complicated solutions. The Gates Foundation ran some contests to develop toilets that use no water and use no electricity. And they've got several models. The winning prize for the Gates Foundation was developed in India. But the problem is with anything like that, if you have any copper or anything of any value in these countries, and you can't get mad at them, they're starving to death. And so they steal it and turn it in and get a couple of pennies and have a rice meal or something. So it's just impossible to have something like that around because it's not maintained and it doesn't last, and it just simply gets destroyed. So it's a very, very serious problem that we're working hard on here. So Heifer International is a group that I've been involved with for some time. My wife, Mary Ellen, who's in the back, has been probably involved a lot longer than I. She's raised money for them for quite a few years. They're a nonprofit humanitarian organization. They're not a relief organization, so something like the earthquake that happens in Nepal, that's not a Heifer project. We're not equipped to, we don't have the expertise to do that kind of stuff. So our goal is to end world hunger and poverty by providing livestock, trees, and the trees are for fodder for the animals, for feed for the animals, training and other resources to get people out of poverty. The average farmer in Africa and Nepal makes about $1.25 a day. If we can get them to $2.50 a day, if we can double their income, they're up out of the poverty zone. They can live on $2.50 a day because, granted, they're growing their own food. So that's our goal. That's what we do. We pride ourselves on a holistic approach, so we go in and don't just try to teach people how to farm and say, here's an animal, you're on your way. We try to build social capital, and I'll explain a little bit more of that in just a second. But I'm saying that it must also include sanitation to ensure success. And the organization is working on it now, but the problem is a typical Heifer project with a family is about $330. And the toilet that I showed you, that one picture there, I've got some more of, that toilet costs about $330 material. So adding that toilet to a family doubles the cost of the project. And so that's the problem. So this is how Heifer goes about their work. They have a three-pronged approach from the technical perspective. One is to increase the income and assets of the person, so to get them to $2.50 a day so they've got enough money to live on, in addition to creating food security for their family and nutrition, making sure they're eating things that they like to eat. We don't go in and try to change their diet for them, although we'd like to. There's a lot of goats in Nepal and India. They love to eat goat meat. They don't eat beef cattle, obviously. And we'd love them to drink the goat's milk, but they don't. They won't. They don't. They're in Africa. They drink the milk. It's a great. Goat's milk is highly nutritious and really makes AIDS drugs very effective. But that's all we do. We work with them. Whatever they eat, and we try to help them grow it in a better way. And then we also try to help them improve their environment. And therein lies the sanitation issue. It's as big a piece of it as anything else. So we work pretty hard with them to solve it. And now we want to move to a point where we never leave anybody without a toilet in any of the projects. The social part of it is, number one, women's empowerment. Women in those parts of the world are very heavily discriminated against. They do the bulk of the farming. They also have to collect the water during the day. Particularly in Nepal, don't have water lines like they do in Central America. So they go out, collect water. They also cook with wood, so they have to go collect wood. And then at the end of the day, after they've fed their family, if there's anything left, they get the food. So it's pretty well known in the developing sector of the world that unless you solve the women's problem and the heavy discrimination against women, you won't be successful. So all of our projects are women-run and women-owned. We try to get the land into the hands of the women. That's unusual. Usually women don't own land. And then we start the training with them. It works pretty well, oddly enough, because like in Nepal, for example, the men aren't there often. In some of these communities, we went to some communities where we were just starting and sat and talked with the women, and there were very, very few men in the audience because they're off working in some other country because that's the only place they can get work. So they're over in Bhutan building hydroelectric dams. They're in United Arab Emirates working in hotels, that sort of thing. And they go away on 2-year contracts and they come back. We were traveling back and forth between India, Bhutan, and Nepal, and so we were in some airplanes with these guys when they were traveling. Quite a few of them speak English, so we were able to talk to them. It's a very unusual situation. So it works well to go to work with the women because the men aren't there anyway. So they go through a training program called the 12 Cornerstones, try to build social capital, get the community heading in the right direction. They learn how to handle money. They learn how to treat each other well. They learn a lot about nutrition. They learn how to farm. And so we call all of that the social capital. So we try to build these technical things on top of this social thing, and by multiplying those two together, we get success. So what I'm talking about are these flush toilets, are building these flush toilets. So Nepal has a government master plan that I have a copy of. The plan was put together in 2011 to have everybody with a flush toilet by 2017. Obviously now they're going to be set back, unfortunately, and maybe for good. In El Salvador, they had a sanitation plan that fell apart when they had an earthquake and couldn't recover from that. So that'll be a difficult thing for them. But we traveled around Chitwan and Nawalparazi districts in 2014, and we didn't find any place that didn't have one of these toilets. They were in every yard. This is the toilet. It's a very simple thing. It's got a septic tank in the back. They're not just dumping it into a river. It's got a porous wall, so it's somewhat like it's kind of a combination between an old dry well and a septic tank that we have here in the United States. What we want to do with this toilet is just tweak it a little bit. They don't surround it with gravel and stone, so that's one thing we know that would improve this toilet. They like to build it in hillsides. This is their tool of choice to excavate. They're phenomenally efficient with this tool. They take it and chop, and all over the world you find these in developing countries. So whenever they can work into a hillside, they really can operate without machinery, and they build phenomenal things. It's quite unbelievable. So we want to make this design a little bit better. The concrete's very porous, as you see there, so that the fluid can leak out, and then it goes into the ground, and then hopefully it goes through some decent ground before it reaches the groundwater. But we are concerned that it's flowing out of the bottom as well. That's just rocks in the bottom, that the water as it comes out is not being treated well enough, and so that it's eventually will contaminate the groundwater. So if we could do that, we think we'd have a design that would flow around Asia very quickly. This is, of course, a design that we use in the United States. You talk to people in the United States about what do we do in the developing world, and our answer is build these things. But it had never happened. This is that community. You see that toilet there in the background. There's another one over there. There was one behind this house. So this community had nothing. This was a community that we were just starting in with our heifer project. They don't know how to farm in this community. The reason these trees are dying and are bare is that they climb them in the springtime and chop off all the new growth and feed it to the goats. They also burn the forests and to burn out the leaves and everything every fall. They were burning them. The forests when we were there, just choking the countryside with smoke to create a better environment for new growth for the goats. But it's really critical to understand what they're going through and how they're living in their life. So this woman was sitting there beating the wheat over that log that's sitting in front of her to separate the wheat from the chaff. And that's the life they're living. So there's no way for us to go there and give them any kind of fancy thing to build because they're just not going to do it. They will build that toilet, that $330 toilet. You give them the cement, the block, the tin roof, and the blue door, and the toilet, and they'll build it. That's the agreement. They get that material from the government, and then they build the toilet, and they'll use it once it's built. But any kind of complicated thing we give them, any complicated thing to build or maintain, they're just simply not going to do it because they're just doing everything they can to survive. I mean, she sat there the entire time. She wouldn't really look at us, but the entire time we were touring this village, she was beating that wheat over that log. So it's just very important to really understand what's going on there. That septic toilet is supposed to be pumped out, just like in the United States. We're supposed to pump our septic tanks occasionally, but it's not going to happen there. It just can't. This village that we visited, we drove on that road. We were on the switchback above the other vehicle. They were down in front of us. And it might have been as long as 5 miles that we drove on that road up the mountains. There were quite a few villages, like this little one up here, off to the side where there's no road. They climb up to that village to get supplies or whatever they're going to do. If they have a goat for sale, they haul it down to the road, and then they haul it out with pickup trucks. They built that road with these things, women, for about 5 miles. And you know, you're on those roads and you think, well, that's impossible. They must have had a backhoe, but I've watched them work with those tools. And so that's the life they're living. So anything we design, if we can design something that they can build in the side of a hill and they can use that tool rather than a shovel to dig a hole, it just works for them. And then they'll build it. Otherwise, they won't. There's no way that a pump truck could go up that road. I mean, we were pretty nervous on that road in those little trucks. I mean, we were very high up in the mountains. So pumping them is not an option. So if we can get them a septic tank that'll work well, and they maybe won't have to pump, granted, that's not necessarily the best. But if that's what we can do, then they can have a toilet. Otherwise, it's open defecation for them. If you've hiked on the Appalachian trails, you might have run into one of these things. This is a great composting toilet. The other solution, where we were there in Nepal, is very dry. Up high, they do have a wet season, but most of the time it was pretty dry. So that toilet was sitting up high enough that it didn't have a water problem. But wherever you have a water problem, like Panama, this is what they build. They build composting toilets. Composting toilets are a little bit more difficult. They don't like them. For one, you do have to empty these things out. You have to go into the compost bin and pull that stuff out. Of course, it's full of flies and it's very smelly. It's dirty. So people don't like composting toilets, but it is a good solution where there's a lot of water. And these plans have been developed by the U.S. government. Obviously, you can get these plans. I have these plans for the ones used on the Appalachian Trail. And then the Peace Corps has a nice set of plans that they use. And the Peace Corps loves these composting toilets. But they're not a great solution for the average person, the average household. Obviously, it's quite a bit bigger. It's more expensive, and then you've got this ongoing, almost daily maintenance. But if it's wet, that's what you have to do. So these little red dots were one of those was the community that we drove up to, and so in order to make the development work in the whole area, what we do now is we go in and get a collection of communities that buy into the program. agree to go through the training, and agree to do the whole thing, and no backing out. And then we do the whole community. So the first 5 dots are the first ones, and that would be Heifer's first iteration, and then after that, they leave. When you get an animal, you get the animal pregnant, hopefully you use the milk that the animal produces, and then the first offspring has to be given to the next person. You have to provide the training. It's called passing on the gift. And so the development becomes quite sustainable. The issue right now is the lack of toilets. However, all of these communities, we were working closely with the local government to make sure that everybody had a toilet. And so I was really very excited about what's going on. The name of the town is Kabalash. They had a cooperative that they could join down on the bottom of the mountain. They had a way to get their goats down there. They'd bring them down to that road and throw them on a pickup truck and haul them out. What they do with a cooperative, they can store food and keep the animals to when the price is right, just like we do in the United States. And there the best thing was when there was a festival. Because when there was a festival going on in India, they would buy goats for the festival. So they would hang on to those goats and haul them to market to the cooperative at festival time and get a good price for them. So that's how they get that income, and that's how that thing ends up working out. So very excited about what's going on there. The local government was highly supportive. As far as I know, these projects have not been damaged by the earthquake. We do have projects in the north that were, but these projects were doing okay. So in the last few minutes, I'll just talk a little bit about our goals here at the University of Wisconsin, what we want to do. The first thing we want to do is develop a legal framework which will promote our technology transfer, the Wisconsin idea. And we've got a way to do that. I'll touch on that in just a minute. I personally partnered with Heifer, but we'd partner with anybody, any NGO that we can provide these standards for and say, here's a set of drawings, give them some pictorial method of looking at the type of soil they've got and building a toilet. That's what we really want to do. It'll probably work best to partner with NGOs at a time so that we make sure, that's one of the ethical standards of engineering, is to make sure that whatever you've designed gets built as designed and not changed along the way. So if we can work with NGO partners, then we can make sure that these things get built properly. So, and then we want to ensure that these standards are kept free, that nobody ends up owning them, and that they're at no expense in the future. So we've got we've got lots of resources here on campus. We've got some of the best wastewater treatment experts in the world to work with here. So we want to partner with various resources around campus to promote the Wisconsin idea and transfer our technology where it can be used and open the door for students to pursue the work. If you know college students today, they very much want to change the world and make it a better place. A similar thing happened. There was an uptick in volunteerism at the end of the Vietnam War. We've always had a lot of volunteerism here at the University of Wisconsin. We've always been at the top of the top 5 of Peace Corps volunteer producers for universities in the country. So our students really want to do this stuff. They want to go out there and get this engineering work and do it for communities at no cost. So the implementation, we work with grantors here. We go out and we get grants to do the work. That's how the research is done here. Michael Best and Friedrich is a large law firm. They work in 8 cities across the United States, including here in Madison. They've got about 220 attorneys. They're a very well-equipped environmental firm. So they have agreed to do the legal framework for us and work with the university to provide, to end up that they're going to build us a legal framework that we can go out and give this work away and not have to worry too much about some sort of legal liability for the professional engineers involved. After that framework is developed, we'll be researching those toilets. The first thing you do is you do a literature review and find out everything that's out there. Don't want to reinvent the wheel, so we can improve upon what's there. We have the Nepal design, and believe it or not, that is the drawing they use, and that's common. That's not unusual at all. So we want to end up with a much better drawing and with specifications clearly laid out that they can build these things and make sure that they work a little bit better. As I mentioned, the designs are in place for composting toilets as well as full septic systems like the ones we use in Wisconsin. A lot of that work was done here. The university has a research station up in Black River Falls where they actually build septic systems and test them. And so that stuff's all in place. We don't need to reinvent any of that. What we want to do is have a very simple septic system that we can hand out that they're willing to build. So with that, I'm going to open it up for questions. I think I'm right on time, Tom, but all right. Thank you.